Here we are in part 3 of atmospheric pollution. College Board has an order that I don't quite understand here, but I'm following it nonetheless, so we're just going to go with it. Um, so, for some reason, we're going to be talking about natural sources of carbon dioxide, atmospheric carbon dioxide, and particulate matter. So, natural sources of carbon dioxide should just really be a review of your carbon cycle. Just focusing in on that atmospheric carbon, really just the carbon dioxide, right, is really what we're looking at. Anything that has to do with combustion, so volcanoes, right, when in doubt, always volcanoes. So, volcanoes, wildfires, um, respiration, as carbon dioxide being a byproduct of respiration. Um, yeah, so, it's natural. So review that. Okay. Particulate matter, though, we did talk about it a little bit before, but basically, natural sources of particulate matter are windblown dust. Um, Obviously humans can increase the amount of dust that's blown, but naturally dust is blown into the air. Wildfires with the ash, volcanoes again, right? When in doubt. And then vegetation, so like pollen is considered a particulate matter in the atmosphere. Um, and then sea spray, so the actual salt from the ocean gets into the air in coastal areas. And moving on, which is like such a weird transition, but whatever, going with it. Just talking about indoor pollutants. So there are lots of sources of indoor pollution. You can track tons of stuff on your shoes when you're walking outside or right, walking through the grass, let's say, and you get pesticides on your shoes and you bring them into the house. They can off gas in your house. I'm just thinking about indoor air pollution. Not to mention that just putting air pollution aside, like anything that you are walking on during the day or bringing into your house on your shoes. So that's why my house is a no shoes house. Probably a good idea for you to do it too. Um, right, living organisms are part of indoor pollution. So excrement from mice, right? Like if you find mouse feces, it can aerosolize and get into the air. Dust mites, mold and mildew, all of that can be in the air and be toxic for you as a human. Tobacco smoke, of course, if someone's smoking in the house, definitely not good. Formaldehyde is a volatile organic compound in building materials, and we have limits here in the United States. It's still in our building materials, but in developed countries, those standards aren't as strict. Radon, which we'll talk about, and also fine and ultrafine particulates. So, one of the indoor air pollutants that we want to talk about is carbon monoxide. Hopefully, everyone has one of these carbon monoxide detectors in their home. If you don't, go get one because they call it the silent killer. You don't know that you're being poisoned by carbon monoxide, and people die from it because basically what's happening is that the hemoglobin in your blood that carries oxygen around is taken up by that carbon monoxide. It bonds really readily. And so that hemoglobin isn't available to bring oxygen to your body. So you end up asphyxiating and you end up kind of falling asleep before that you actually die. So you just kind of get sleepy and because you're low on oxygen. And yeah, you're basically being smothered. And so people don't realize it's happening. And so that's why the smoke detector or the carbon monoxide detector is really important. Radon is another indoor air pollutant that's really common. So some geologically, depending on where you are, some bedrock is higher in uranium than others. And radon is part of the uranium decay series, right? So uranium is radioactive, and as it starts breaking down, it forms into radon gas, and that radon can seep into your basement and into your groundwater. And radon is the second cause of lung cancer in the United States. So radon is not good for you. You can see that maybe some of you guys actually have this on your house, these radon mitigation systems, where basically it's just a tube with a fan that just blows the air out of your house and doesn't let it seep into your basement. It's pretty simple, but highly effective. I know that in North Stamford, a lot of well water is contaminated with uranium. And so I know the government was giving out, or the Stamford government was giving out uranium filters. So maybe you guys have that in your house too. So take a look around. VOCs and formaldehyde. So remember, volatile organic compound is anything that can actually like that evaporates really fast at a low temperature. So like acetone, like nail polish remover, right? But it's also in other stuff like paint and paint thinner, caulk, stuff like that. Finish like like any kind of wood finish. Hexane is also in paint, right? Adhesives, gasoline, anything that's around your house. So think about, right, building materials and stuff like that. There are a lot of VOCs and formaldehyde in those materials. Plywood, particle board, carpeting, right? All of those things have these VOCs in them, and they need to like off gas when you first buy them. And so that's why things have that smell, and you kind of let them sit for a few days and then they off gas and it smells a lot better. Right? Those are not good for you. In developing countries, right, you have a lot of particulate and carbon monoxide and carbon dioxide pollution in the house because of wood burning stoves inside the house. And so, that leads to a lot of air pollution inside. And so, obviously, in reducing air pollution, indoor air pollution, there are a lot of things that you can do. In developed countries, we banned smoking inside. When I was growing up, restaurants had a smoking and a non-smoking section. Now that's the thing of the past. That doesn't exist anymore. We also have strict standards for formaldehyde levels in materials and stuff like that. And then we also have less harmful cleaning products available for us to use. So like instead of having those ammonia-based products or like bleach, like something really, heavy, you can do something a little more natural and less harmful to you. And in developing countries, like I said, those indoor stoves are really what is causing most of the air pollution inside. And so by creating stoves that are vented properly and are burning more efficiently is one way. Another way is the use of solar ovens, which I have one. I made cookies in it. It works. It gets really hot. But basically you're using the sun to cook your food. Pretty awesome. So moving on to the reduction of air pollutants, and we're actually going to go back to like the atmospheric air pollution instead of indoor air pollution. Like I said before, the order is kind of weird for me, but going with it. So there are lots of ways to control pollution, regulatory being one of the biggest ones, I think. We've talked about the Clean Air Act and just limiting the amount of the criteria air pollutants that a company, industry, an individual, whatever it may be, is allowed to emit into the atmosphere over a certain amount of time. And so, just law is a great way to regulate pollution. Another way is through emissions trading or something called cap and trade. It was done for sulfur dioxide and worked really well. Basically, a plant is allowed to emit a certain amount of a pollutant, and it either pollutes just that much, or if it pollutes less, then it can sell the credits to another plant that is emitting more. And so really you're putting an umbrella cap over how much is actually allowed to be emitted and distributing it between different industries or different plants. And then they are trading between each other how much they can emit. So, someday maybe it'll be available for carbon dioxide. There's a lot of talk about that right now. Another thing that you guys might hear about is called carbon taxing. So basically, industries are just getting charged a tax on how much carbon dioxide they're emitting. So, someday I hope it's coming down the pipe. But carbon dioxide is not considered a criteria air pollutant according to the Clean Air Act. So, it's slow going at the moment. There's conservation control measures. So basically like conserving fuel and, reducing energy use. And then of course, using renewable resources would be the best way to control pollution, because you're actually not emitting in the same kind of ways that you're emitting by burning fossil fuels. So alternative fuels is a great way to control pollution. And if you download the PowerPoint, you'll be able to watch this little video on cap and trade. So if you still want to know more about it, by all means, watch that video. So in looking at different pollution control measures, obviously vehicular or motor vehicle pollution is massive, because there are so many cars out there. And really we're looking at the combustion engine. We're not talking about hybrids, even though it is half combustion engine or electric or anything like that. But basically, a regular combustion engine has a couple of ways to control its pollution. So at the pump, those special gas pump nozzles are actually reducing the fumes. So it has this way to recover vapors and to reduce the amount of vapors going out into the atmosphere. So if you ever wondered why the nozzles look the way that they do, that's why. And then just in driving, a vehicle with a combustion engine has a catalytic converter. And what a catalytic converter does, without getting into the nitty gritty of it, is it actually converts emissions into less toxic molecules. So looking at hydrocarbons, carbon dioxide, nitrogen oxides, goes through the catalytic converter and comes out as less toxic molecules such as nitrogen, water, and carbon dioxide. So something a little more heavy duty, especially when we talk about industrial pollution, or even energy generation, like a coal power plant or something like that. You need to use really the big guns. And so the next few methods are kind of involved, but basically we are trying to scrub the air of whatever pollutants are in it. So if there's right, this is a wet scrubber, which obviously by its name I would imagine you could say, hey, there's got to be water involved in there somewhere, and you'd be right. So basically, right, the air is coming up through the scrubber, and you just have this fine mist of water to try and basically knock out the particulate matter. So just weigh it down and have it fall to the bottom. And then also the sulfur dioxide in the air, or in the emissions, are actually passing through a limestone slurry. And so it's actually reducing the sulfur dioxide in the air that is actually exiting the emission stack. And so it removes a lot of sulfur dioxide, and it removes a lot of particulate matter. It's pretty expensive to install and maintain because most of these are retrofitted, and ultimately can't reduce the hazardous, really fine and ultrafine particles. It can only really knock out, the larger particulate matter. So a dry scrubber are used more often, actually, I think because they're a little less expensive. Although they are expensive, they're a little less expensive than a wet scrubber. And so basically you have dry reagents that are added to the gas to neutralize those pollutants. Usually like sodium bicarbonate is one of those that they put in there, just baking soda. But then there are other obviously dry reagents that they kind of shoot, like they let the gas pass through. And so that gas kind of gets scrubbed with those dry particles. And then the gas actually goes through a physical filter to get the particles to come out of suspension. And then that powder is collected and then disposed of. Obviously, it has some toxins in it. And so, that's another option. Last one I'm going to talk about is called an electrostatic precipitator. I will say that this is probably the most expensive. It uses a lot of electricity and it's kind of, a little more difficult to maintain. But basically, and this is like, pay attention to this picture on the right side here because I think it really helps. So you have the emissions going up through like a metal grid that gives them a negative charge. So as these molecules are coming up through this electrostatic precipitator, they're giving a negative electric charge. And along the sides are these positive bars. And so the negative molecules are attracted to the positive bars and get kind of, well, not kind of, they get electrically pulled out of the gas, and then the waste gas without the particulate matter actually gets released out into the atmosphere. And so, right, they're using an electrostatic charge to get rid of this particulate matter. Then you have to get rid of it as well. But like I said, it's very expensive and it's really only reducing particulate matter. And so a lot of times, wet scrubbers, dry scrubbers, and electrostatic precipitators, those are used on coal burning power plants a lot because they are so dirty and have so much particulate matter. And so that's it for our pollution control measures. Stay tuned for our final installment of atmospheric pollution.